Welcome and hello. This is an update video in HEC HMS, and I'm going to be discussing the modified Kling-Gupta efficiency, which is a new feature that's been built into HEC HMS version 4.13. The Kling-Gupta efficiency, or KGE, as well as the modified Kling-Gupta efficiency, which I'll call MKGE, are statistical performance metrics used to evaluate the accuracy of hydrologic models when comparing the model results with observed data. What I have on the screen here is what it says in the HMS User's Manual, modified Kling-Gupta, and it's used for an optimization trial and calibration statistic. So the page I'm on here is going to be the first link in the description of this video, where it's talking about 4.13 release notes. These are new features or improved features, as well as bug fixes. So here we are. There's no tutorial with this one, but that's what I'm going to run through in this video. There is a link to the user's manual and technical reference manual, though. All right, I'm going to fire up my HMS 4.13. Here is a model that I already have prepared. And at the outlet here, I have observed data. So Arroyo Seco _USGS. This is a stream gauge. So if I click on options, I have some observed data right here. Without further ado, I'm just going to run the simulation. So click the run button, let that run. Okay, that's done. Now let's check out our results. So I'm going to right click on that sync view and then click on the graph. Let's just look at the graph first. Okay, so it looks like it's a pretty good fit here. The black data source is the observed data, and then blue represents the modeled results. I'm going to right click, view results, and summary table. And then here we have the modified Kling-Gupta value of 0.883. MKGE is used to address some of the limitations of more traditional metrics, such as Nash subclass efficiency, which is right here, NSE, and that's 0.928. A little background on KGE and MKGE. I have the notes from ChatGPT up here on the screen. So we have the equation right here. Basically, 1 is the perfect score, where 1 minus this term right here is KGE. The term R, beta, and gamma are defined here as the Pearson correlation coefficient. Beta is the ratio of simulated to observed mean values, and then gamma is the ratio of coefficients of variation. So the modified version just swaps out this gamma term for an alpha term. Here's the modified MKGE now. This alpha term is now the ratio of simulated to observed standard deviations. So the optimal value for MKGE would be 1. That was my next question. Here's a table. Basically, 1 is perfect. And then the closer to 1, the better, but it could be as low as negative infinity. So basically, the lower the MKGE, the worse the score. The specific number that is acceptable for your model, that's sort of up to you. There is a page in the HEC HMS technical reference manual that talks about all of the calibrated summary statistics. Here's Nash Sutcliffe. Here's the equation for it. If we scroll down to modified Kling-Gupta efficiency, here's the same data that we were just looking at. And then at the very bottom of this page, we have a table that shows performance ratings. So here are very good, good, satisfactory, and unsatisfactory. You notice we don't have MKGE column in this table, and that's because performance ranges for MKGE are not provided, but an MKGE of 1 minus root 2 or negative 0.41 is considered what you would get for the mean flow predictor. And basically, the higher and closer to 1 you get, the better the score. All right, so let's go back to our model here, 0.883. That was the calibration statistic. Next, this also shows up in optimization trials. So if we wanted to run a model that optimizes this MKGE parameter, we can do that. So I'm going to go to Compute Optimization Trial. I already have an optimization trial set up, so I'll show you what that looks like. I'm going to click the Compute tab right here, and then under Optimization Trial, I've got one trial ready to go. And what I'm doing is setting the objective to maximize, and then the statistic is modified Kling-Gupta. My two parameters are, let's see, parameter 1 is the green ant sorptivity scale factor. Sorptivity is also new to 4.13. And then parameter 2, I'm using green ant initial content scale factor. All right, so I'm going to run the optimization trial now. Trial and run. Okay, that ran. Let's take a look at the results. I'm going to click on the results tab here, scroll down to optimization trials, and then first let's look at the objective function summary. So when I click on that, our max value is 0.93, which is much closer to 1 than what was it last time? 0.883. Okay, so moderate improvement. And then a few other results we could look at is the objective function value. This plot shows the objective function value as the optimization routine runs through a number of different evaluations. And you can see that 0.93 appears to be what is maximum. All right, I'm going to close that. If we want to visit the details on the modified Kling-Gupta efficiency, these specific terms, we're not seeing the R term, the beta term, or the alpha term, but we can actually get that data if we go to our project directory, and then in the results directory right here, we have a .results file for each of our runs, for each of our simulation runs and our optimization runs. So let's look at the first one, the simulation run. I'm going to just open up this file in a text editor. Okay, it's right here. It's looks like an XML. And then if you scroll all the way down to the bottom, and then let's see here. Let me make this a little bit wider. Yeah, the last 4 lines here have the modified Kling-Gupta, correlation coefficient, variability ratio, and flow bias ratio. So those values should all be fairly close to 1. If we scroll over, we can see the actual values here, 0.883, because that was our simulation run, not our optimization. That was the actual Kling-Gupta value. And then the other 3 values that are used to calculate that 0.883 are 0.983, 0.910, and 1.072. Going to close that up. And then for the optimization run, we have similar results and a similar way to look at the details. So I'm going to open up this .results file associated with the optimization run now. Okay, here is that file, another XML. And then let's see, I'm on line 10 here. It may be a little bit different for you, but it says maximize, which we're trying to maximize the MKGE parameter. And then here are the individual values. Here's the MKGE for optimization, 0.93. And then we have correlation coefficient of 0.99, bias ratio of 1.02, and variability of 0.93. So those are how to find the actual details of the MKGE calculation. And that's it for this update video, where we talked about the MKGE statistical performance metric that's new in HEC HMS version 4.13.